Bazinga.
Bazinga. All right, which ones would you like?
64.
64.
64 and a half.
That is a fantastic problem. Absolutely fantastic. All right, so we have limit as n goes to infinity. Of the sum as k goes, they didn't use k though, did they? They didn't read it. Here, y'all read this out to me because I'm butchering it.
Which one is it?
This
Number
64.
64, yeah.
Limit as n approaches infinity, pi over 2n, summation n on top, j equals 1.
Okay.
Sine
Parentheses, okay, go.
pi over 3
Huh?
minus pi over 4n
Pi over 4n.
plus j pi over 2n. J pi
J, I
over
got you.
4.
Okay. J pi over 2n or 4n?
4.
2n.
2n.
Okay. Sweet. All right. Here's what they want to do. They don't expect you to actually crunch through this stuff. What they want to know is, what is the function that I'm using to take my area, and what is the interval? Okay? So this is sort of the Jeopardy question. Usually we see, here's a function, here's the interval, and then we set up the limit and the summation. They want us to work backwards. They plugged all this stuff in. Now they want us to figure out what the original function was and what the interval is. Got it. Okay, where would you like to begin?
So we want the function. Wouldn't the interval be
Tell you where I would start first. Probably the easiest thing to do on this one is to determine the width, the delta x. Okay?
is it pi half?
Where do we look to find it?
The big version.
This little guy right here, that's our universal width that we had factored out. And for us, our delta x, or our dx, is b minus a over n. We have pi over 2n, which would be the same thing as pi halves over n. So for me, I've got a delta x on this one as a bit of scratch work. My delta x is going to be pi halves. Okay? We got that from here. Now, lots of different things could have happened. We could have gone from 0 to pi halves. Or we could have gone from pi halves to pi. Or any other combination. So what we need to know before I can answer this is, where did it start? Okay?
1.
How do you know that?
Because j equals 1, that's where it started. But,
What does this mean?
no, that's, never mind.
That doesn't tell you where the interval started, that tells you
What rectangle?
which rectangle, first rectangle, second rectangle. So that one's pretty much always going to be 1 for us. Okay? Any ideas?
No, I was clearly lost during this
I'm
one.
gonna-
That's why I asked you.
I'm gonna guess.
Wait. Here we go. All I'm doing here is writing our general formula, the one we've had up on the board a couple of days now. Okay. That's the formula we should have in our notes somewhere. Excuse me, alright.
Oh, we started Pythagoras
How'd you get that?
because, I lost.
Okay, because, I like
Because,
it.
because, I don't know.
Yeah, the one number that's just kind of starting it all off is your pi thirds. So this is our A.
Without, because it doesn't have an N or.
Because we don't have any extra K's or N's or anything like that tacked onto it. Okay, so I'm gonna start at pi thirds,
So pi halves.
and I'm gonna end pi halves later. Alright, so again, more scratch work. If I do pi thirds, and I'm going an extra pi twos, common denominator is gonna be 6, so we're gonna get
2 pi 6
2 pi 6 plus 3 pi 6,
pi 6.
so 5 pi 6.
Oh, 5 pi 6.
Okay, so there's the window from pi thirds to 5 pi 6. We got the pi thirds because that was our A value, this constant where we started, and we knew from this that it was pi halves away. Cool. I'm also gonna be a little brave and say our function is probably gonna be sine of something. Okay?
I'd say so, something like that.
Okay, so now we gotta figure out what the something is.
Hmm.
Dun, dun, dun.
Okay.
So that leaves this.
Which, we have a J in there, which is our substitute for K,
Yeah, one part of it.
on one part of it, and then the other part is pi force N, I mean, yeah.
What to do, what to do. Well, alright, you know what? Let's do this. Let's do this. Let's take this part right here that's
We
left
can
over.
say that, we know that, the last part is the K times the, cause it's J pi over 2N, so that's the last part of the K.
The J and the K is not bothering anybody, right? The fact that they swapped out the letters? Okay.
Cause it's, in the original, it's K parentheses A minus B over N, that's A minus B over N times J.
Okay, if we go ahead and recognize that this was A and sort of push it out, here's what I'm thinking, all this stuff that's left over, this negative, and I'm gonna write it as pi force over N plus J times pi halves over N. Is everybody okay with that? Alright, that is supposed to be this. Okay, that's that thing.
Which means it's just sine of, what would it be in this case? Sine of, X, sine of X.
Just X.
Well, if we're grouping that all as being that part over there, what's left is, there's nothing left, so you just,
I'm sorry, I should have written that out of all that. Okay, that makes more sense now.
negative pi fourths x, sine of negative pi fourths x.
This to me, honestly, is the x part. I'm reading that as
That's the x.
x. Kinda. Actually, no, I'm sorry.
No.
I'm reading that as this,
Yeah.
b minus a over n.
That's what I was saying, that's the b minus n over.
Right.
So the leftover, that's the leftover mid part.
Correct.
Which would have to be part of the function, which is the, that's what I thought was the negative.
This is not, okay, let me ask you this. This part I like. I like when I see a pi 2's because I know that belongs to the b minus a over n. So
Is it
what would I have to do to pi 2's to make it
One
over
half, one half.
negative?
negative 1/2?
Yeah,
So is it sine of negative 1/2 x
negative 1/2
plus x?
plus x. That's the way I'm reading that one.
So x minus 1/2.
Or x minus a half. The way they've got it ordered, this is what I would write, but there it is.
Ta-da.
Not the greatest one in the world to do, not the easiest to jump into. I think some of the other ones are a little bit more user-friendly, but there we go. Good that you recognize starting point A, interval, okay, or width, which gave me the interval. And then we somehow had to finagle this into that by recognizing that this constant little pi 2's was hiding in there somewhere. Very cool, yeah. Very, very cool. There would be my answer.
Bam.
I don't know that I would have checked that. I probably, if I were teaching or doing some examples, that would not have been the first one that I would have gone with. But it does a really good job of illustrating it.
How hard it is.
You wanna try one or two more of those?
Yes.
I think this concept is a little screwy in the head. Let me make one or two up. May I? Everybody got what they want?
You have to check the person in the notes of the other people. Good job.
Okay. Let's start a little bit easier. So this is a made up example. Try this one. Limit as n approaches infinity of summation as, I like my k's. K goes from 1 to n of 3 over n times the natural log of let's say I plus k times 3 over n. Okay, let's start simple. All right. Your job now is to identify the original function and the interval on which we are taking an area. And action. You do look like you're in pain.
I can't comprehend.
So we could say that the delta x is 3.
Good, let's pause there. Does everybody see why delta x is 3?
Nope.
All right. Let's leave this up here. Let's not, don't let me erase this again. Limit as n approaches infinity of the sum. K goes from 1 to n of b minus a over n times f of a plus k times b minus a over n. This being our width, universal width, and this being the actual function that we plugged it into. The width I'm looking at is 3. B minus a over n, the b minus a tells me how far it was from starting point to stopping point. This 3 tells me that the delta x was 3.
Okay,
Okay, you okay with
yeah,
that?
I got it now.
Now, what I don't know is where that started and where that stopped, but once I know where it started, I know that it will end 3 units away,
Okay,
all right? So for that second part, I look
Yeah.
here. This one started at 5, okay? So it's gonna start at 5 and it's gonna end 3 units away from that at 8. So my interval would have been from 5 to 8.
okay,
Does that make sense?
yes.
All right. Now, the original function is all the stuff that's left over here. I'm gonna say it probably has something to do with the natural log. All right? The natural log of what?
X.
Just
X.
x. Okay, here's how we got that. The a itself, we already know that starting point at 5. This looks exactly like this, so nothing fancy has been done to it. This is just good old natural log of x. Okay? Now let's put a little stank on it.
Not much stank.
Alright? How's about we try limit as n approaches infinity, the sum as k goes from 1 to n of 2 over x, or 2 over n, excuse me. Excuse me.
Oh, the brackets.
Yeah. Oopsie.
I see you go 0 to 100.
I'm talking to, she's a nurse after this. I'm forget Advil.
Good, yeah, go to the store this weekend and buy a bottle of
I
Advil
have some,
just
I
for
keep it in
you.
my car. I had to take some yesterday right after school with them before the open house started.
Because of me?
Yes.
Because it's fun.
Okay, this sounds
That
fun.
warms my heart.
Does it really? Did I just think about this?
It does, yeah. This is good. Today's gonna be a light day, so these are good questions to be asking right now.
Okay.
Okay, let's do the easy part.
2 is your.
What is my delta x?
2.
Or dx? In this case, it is 2. Good. Now, you let her be pain, okay, or everybody else that wants to try this.
Okay.
Okay. Do you get where he's
Yeah.
pulling to?
I
So,
get where he's getting
this
from.
2, so what I need to know now is where to start, and then from that starting point, I will go 2 units over, and that's where I'm gonna stop. You wanna go out on a limb and tell me where it starts?
Oh, man.
Anybody, except Michael. Do you know?
Yeah.
Okay. Ray, what do you think?
Well, I guess I can guess.
Be focusing. What do you think?
-5.
-5. No.
I have a guess, but I don't even know.
What's your guess?
-1.
-1 is correct.
Dang it.
Yay.
Just suck it in. Suck it in.
At least I know I got something good.
Okay, talk me through it.
Oh, how I got -1. Well, most of it's gibbity goop, except for the -1, the 5, the -4, and the -1, and the cube. So -1 cubed is -1 times 5 gives you -5 4 times negative 1, which would mean plus 4. So you get negative 5 plus 4 equals negative 1.
That was the most roundabout way of doing it. You got so lucky on this problem. Because this is why the answer is negative 1. Simply because those are negative 1s right there. That's it. It's the most ridiculous way of getting that answer.
It worked though.
Holy crap, dude. That was bad. Oh.
You got the right answer.
Oh, that hurt my head. Okay.
I have to leave my car.
Look at the formula, yeah, I have some stuff. Look at the formula, look at this, look at the formula, look at this, look at the formula, look at this. This mess right here, this A plus K interval gets plugged into F, okay?
So all that is really just F.
All of this is really where an X would go.
And all that goobity gop, that's really the 5 to the cubed and all the minus 4, that's the function.
In fact, that's the function, yeah. Our function is going to
5x
be
cubed
5 blah cubed minus 4 blah. Okay? That's the X where we plug all that crap in.
Is that it?
And then,
For this, yeah.
okay.
5 plugged in that junk cubed minus 4 plugged in that junk. This is the reason that it starts at negative 1,
That's
not
pretty-
whatever he just said. Man. Okay, well, let's get the last part. If it starts at negative 1, where's it gonna end?
1.
Positive 1, good.
You should've made it not so the way I thought and the way you thought.
Yeah, I
They're
didn't,
different, but they
I,
come with the same
I didn't
answer.
put that much thought into you coming up with that ridiculous answer.
That was perfectly reasonable.
Holy crap, no it wasn't.
That was completely reasonable.
Ridiculous.
It worked.
Let's try another one. Let's do some from the book. There's one.
Oh,
Juicy
great.
one.
I would call it juicy. It's alright. Alright.
Cause I
As I limit as n approaches infinity. I'm gonna write it the way they have it here. Excuse me. 5 over n. Summation. K goes from 1 to n. They use j's, I think. We don't use k's. Okay, they didn't, alright, hang on, they didn't do this. But that's cool, we'll talk about why it's the way it is.
they did something special.
Well, you'll see what they did, hang on. E to the negative E to the negative 2 plus 5 K times 5 over n. Okay, there's one I'm gonna erase something here just a second, but there's one teeny tiny difference in this example and the last two examples.
Well, there's n minus 1. K equals 0.
Good. So, do you know the difference between these two and this one?
Is there a different equation for that one?
Yes.
Isn't that from the left?
Yeah, these two were both right,
That one.
this one was left.
Oh, so that's the one you didn't show us.
Well, it doesn't matter, because if you go to infinity, all the rectangles squeeze. You could just as easily have done this, and now it's a right problem.
Yeah.
Okay.
You can really
Okay.
change it.
Just as easily done that, which I think is probably fine for us as well. Just recognize if you see that, especially going towards infinity. Now, if they aren't going towards infinity, we gotta treat it like left. Gotta leave it left. But because we're going towards infinity, you're just squeezing all these rectangles together and it doesn't really matter. Okay, we need the function.
5.
Hang on. 5 is an important number.
That's
It
a
is not the function, it is an important number though.
Something's
5 is your delta x, good. That
Delta
5
x.
there tells us that it's gonna be a distance of 5. Once we know where it starts, we'll just plug in 5 and we're done. For bonus points, where does it start? -2, very good. There's my a value. Okay, so if we go 5 from there, that puts us at 3. What was the function? That's it, e to the x.
Yes.
Nothing fancy, this is the whole a plus k thingy plugged in, so, ta-da.
Bam.
Okay.
Booyah. Does that help?
Yes.
Good. Alright.
So, good point.
Good, good, good. Everybody cool? Alright. Yeah, that right there will now be a quick and easy thank you for my points. I appreciate it. Hopefully. Cool. Good questions. Alright.
On helping me my way to my 5.
Do it. Helping you on your way to your 5.
Yeah, that's what I'll put every time I do more.
Make sure you do that after you've answered everything, to make sure you got time. You know, thanks for my 5, but do that after you've already answered.
What if I have like 20 minutes left? Everything is like, thanks for my 5.
Get a stamp. Thanks for my 5 stamp.
You get a 1.
You know,
You got it all right. They just didn't like you. So
You're right, yeah. We don't like copy kids.
Really? You really gonna do that?
They do have kids every year that just, they know they're not gonna pass, so they doodle and whatever.
Easies are great.
Yeah. Yeah, it is. The biggest percentage on the AP test is 1. The kids that get a 1, that's about, 40%, somewhere along in there.
Oh.
The second biggest percentage is 5. So you either know what you're doing or you don't know what you're doing. The lowest percentages is 1.
I think you just said 1 was the biggest.
I'm sorry, 2. Yeah,
Two,
2 is the absolute lowest, and then
What's passing in 3?
3. Yeah, 3 and
So-
4 are usually about the
No,
same.
you don't, either you know it or you're like,
Yeah. It's usually 1 big chunk, 5 big chunk, smaller but big chunk. 2 is the smallest, and then 3 to 4 is usually split pretty even. Those that do it. 2 means you try. Honestly, the 2 people are the ones that tried but didn't learn it well enough. The 1s are the people that just didn't give a crap about the
2 are
test.
like people who had it first.
Because it's really hard to make a 1. You have to want to make a 1 in order to get a 1. Okay, what are we gonna do next? Oh, y'all were about to find a shortcut, weren't you?
Yeah.
Hopefully. All right, let's
How do you do
recap.
something with the n plus 1 over x
Yeah,
plus 1?
okay. We had like 4 or 5 shortcuts on the board yesterday, but they all boiled down to this. If f of x is x to the n on the interval from 0 to b, that the area was b to the n plus 1 over n plus 1. Okay, we can even go one tiny step further, because you did do this technically. If, well, let's do the same function. X to the n, but instead of going from 0 to b, we go from random a to b. Do you remember what we did for that?
We just took both of them from.
You went from 0 to b, then went from 0 to a, and then subtracted it, so the area would be b to the n plus 1 over n plus 1 minus a to the n plus 1 over n plus 1. So these are the two. This one starting at 0, this was more generic if we start at some other point, and obviously if a were 0 in this case, this part would get washed out, so it wouldn't really matter anyway. All right, we tried sine, is that what we tried?
You returned your sign, but
And why didn't that work?
because we didn't know trig.
We didn't have any special formulas for trig.
No.
The same way we had, these work nicely because they're polynomials, and Gauss and Bernoulli gave us some really good formulas for polynomials. Okay, trig didn't work. Well, it technically does work, we just don't know how to do it, okay, yet.
Yet.
How about another function? Shall we try another one?
Sure.
All right, what else is inverse trig.
But we can't figure out the normal.
Can't figure out normal trig, certainly not gonna figure out inverse trig. Alright, logs or exponentials, which one do you wanna try?
I like exponentials.
Exponentials?
I kinda like exponentials.
Who wants exponentials? 1. You don't care, whatever, it's not, whatever, okay.
I don't really like logs.
You don't really like logs? So let's try
Fancy something.
an exponential. Give me one.
E to the 5x.
Don't make it complicated.
E to the x.
Seriously? We can't even do the easy stuff, and you wanna go straight in the, well, e to the 5.
E to the 5x.
Whatever. Give me an interval, 0 to what? We'll keep it simple, 0 to something.
5.
5?
That's what I
You
want.
really wanted a 5 in there.
I
didn't
You really did.
Gotta have a 5 in
Do you
that
like
problem.
5?
No, I actually don't like 5.
So why'd you keep picking it?
Because it was the first one with the top of my head, and
Okay.
because I couldn't do it, I kept thinking about 5 because I didn't use it.
Alright, here we go.
You had to use 5.
Sum as k goes from 1 to n of 5 over n. I'm gonna fast forward a little bit here. 5 over n, so 5 minus 0, 5 over n. And then f of,
E
so e to the
K
0 plus, so 0 doesn't matter, 0 plus k times 5 over n. And you notice from those problems we did for the warm-up or the homework, I kind of like to write it this way because it separates the thing we plugged in. On those, they weren't quite so nice, they went ahead and globbed it all together. The AP, they tend to do more like this, they keep it separated for you, or if they do combine it, it's not that hard to see how they combine it.
homework.
Alright, so that's general right, so now we're gonna take a limit going to infinity. Let's see here, we can pull out the 5 over n. That leaves me with the sum as k goes from 1 to n of e to the k times 5 over n. Alright. Go.
I can find the function, I can find, it's already there. We're good. Oh, good, because we still haven't, I don't know the shortcut. Let's see,
And again, honestly, the only problem here is that we've got k's in it, and we want everything to be in terms of n. So, fine, get rid of the k's.
Can't get rid of it.
take an actual flight.
Well, why not? Let's use one of our cute shortcuts to rewrite e to the k.
Oh, wait, we don't have one.
No, we don't have one of those.
Aw, go back in.
There's nothing equaling, so you can't take natural logs.
Man, I need my new notebook. I gotta get that. I have it. It's in a box.
Well, it appears that, like the sign,
You've been stumped.
we're stuck.
You've been
Shall we try natural logs?
I'd like to say that they're
No.
not the same thing.
Yeah, I think the only ones we've seen that work nicely are these, and that's only because they're polynomials and somebody came up with a formula for them.
A really smart guy at the age of 10.
Yeah, he started the ball rolling, yeah.
I'm gonna be older than 10, but I wasn't that smart.
Not that smart at 10.
No. I don't think anyone's that smart at 10 anymore. Dang it. Does this mean calculus is over?
Yep, we're done. Good luck on the AP.
That's a terrible thing to say.
So now, are we right here?
110.
We got 30 minutes.
Yeah.
You got 30 minutes to figure out what this
Has to do with everything.
really is.
Aw.
I will give you a hint.
It has to do with everything.
I'll give you a hint.
It's not just all numbers, it's everything.
It is in your notes somewhere. That picture
This,
is in your notes somewhere.
Just in all of, from like what we're taking
Yeah.
throughout the year.
Yeah, it's in your notes somewhere.
Why are you doing it?
Should take a nap now.
everyone steals stuff. Okay, math. Let's see.
Can I take a picture?
You can probably fast forward, alright? When you see me back on the scene again, might wanna hit play.
Okay.
So really what we're trying to do is figure out what this has to do with everything.
Yes.
Did I ask my friend Lucas?
Are you texting him?
I could. He
Who
takes
is Lucas?
calculus. He takes calculus in
He'll give it
Carolina
away.
Forest.
He might give it away.
They might not learned it yet.
I don't know,
They have like they learn it differently. That's from what he told me.
Yeah. They do, the teacher over there gives them homework assignments where they have to
They watch videos.
watch
and
video,
then-
like 10, 15-minute little videos where she teaches the
Mhm.
lesson, then when they come in the next day, they do practice problems based on what they
Yeah,
watched
that's
the
what he
night
told
before.
me.
Which is, I guess, is kind of what the fourth blockers are doing. What are you doing? You can look through your notes.
Okay.
Truth be told, he probably won't text me back till like the next
Done.
hour.
Who took good notes from first semester?
I
First,
don't-
Ray,
oh,
you know?
first semester. Oh, I know.
What other time would there have been?
Well, I thought you, when you said notes, I didn't think you meant first.
What other notes have you?
When did we,
Seriously?
we did, we were doing this.
I fell asleep. Someone help.
I can't walk over there or they're gonna stop the camera. Can one of y'all hand me the water bottle?
So am I just gonna be scared?
Oh, I know,
If it helps, do some examples.
If I remember when we used n, there was something with n+1. We did that. We did that before,
Let's see.
and it had to do with.
I'm looking at our old limit stuff, but it's not helping.
It had to do with taking.
Let's hope I was actually in
Limits.
class that day.
It did have to do with limits.
Do I?
Let's hope I was actually in class that day. Because then I might not have taken notes.
Yeah, you were there.
I was there. Hi, Sloan.
This
Sloan,
is
what
the
is
part
it?
in the camera where y'all are gonna be fast forwarding.
Because we're just sitting here because we.
I did make a note, I said fast forward until you see me walk back on the screen, so this is where we all be.
This is the
Or
part where-
Sloan could just tell me the shortcut.
Or they could
Also
also
haven't figured it out.
or they.
We did do some practice problems, so to be fair, we've only been looking at this for about 4 minutes.
Well, make me wanna beat my head
I
out.
know, right?
Shut up, Sloan.
We're gonna feel really stupid when we tell them to help you.
I won't say stupid, no,
I don't know if we would've done this.
no, I don't know that it would've been that obvious. If it helps, look at the examples from yesterday with the actual numbers, okay? But the thing I'm referring to in your notes is from last semester.
They were begging me to tell them yesterday.
Did you tell them?
No.
I'm gonna make sure I erase it before they come in here, and so they can.
Yeah, and then in that little page of notes, we'll just like save it to the side.
Yeah, well, yeah, don't print that page out yet, hold that one.
That's a terrible thing to do.
We tried e to the x, we tried, maybe we could come up with a pattern for that, but then we got stuck.
You black marker.
I do.
What happens if they come in, if there's no, they must see it?
That's okay, they'll join the search with you, it's fine.
Are you really not gonna tell us
I'll give you
today?
a hint, it has nothing to do, you can't do
I
anything with
just
e to
don't
the
know
x.
best to find the.
Is it? I can't do
Yeah.
it from the
Hey,
screen.
Ryan, no, either way.
I can't do anything with sign either. Isn't
I'll
that
go
so
ahead and
funny?
say it, no,
Dude, this
but
takes a
once you
while.
figure out
Yeah.
what that truly means, then the sign and the e and everything else
I was
won't
thinking.
matter.
Cause really what we're doing
plus one over what we had plus what we did to it, so I was thinking if it's sine, would it be?
Stick with polynomials.
Okay.
Dang it, these are my notes from yesterday.
What do you mean by stick with polynomials?
I realized
Think about
that.
polynomials, don't think about anything else, think about polynomials, and make the connection with that, the
I
polynomial.
sit with all of them.
And then once that connection is made, then you won't need to worry about any of the other functions.
Oh my god.
Well, I think Smart can't like it.
It is in your note, who took the notes from first semester?
I've taken notes,
Graham, you
but I
taken
haven't
notes from
seen.
first semester?
I'm not sure.
I think if anybody's, it would be yours.
It had to be in hers. Oh, and they said always use her notes. She writes good.
She always,
Yeah, my notes are too small.
Sorry.
It's okay. I can read it.
What is that?
What is this crap? Ah,
I stared at one of them, I'll just get it.
Well, I don't know, let me have you write something down, hang on. You might wanna go ahead and hit play now.
Well, they see you, so.
I know, that's why I'm staying here long
Do
enough. so I can
some
play.
crazy
Ready?
dance moves.
I'm here. Alright, erase this crap in the middle.
They can hear us, this crap right here.
Ooh.
Yeah, yeah, because that didn't do us any good.
This is.
Oh.
Alright, let's just do a few examples.
Oh, I
Just do a
thought
few
there was someone else
examples.
in like other room just watching us.
No,
We're
there's a
just so
camera right
comfortable.
there. Alright,
Mr. Freud.
here's your
and
function.
paparazzi
Let's
and
try f
sparks.
of x is x to the, x to the fifth. Okay, and your interval is from 0 to 3. Okay,
You're just trying to do as much as you
I'm trying to give them some patterns to see. Alright, now, tell me what that area is going to be.
That area is going to be, so, b is 3 to the n power.
About 27.
It's gonna be 3 to the 6 over 6.
3 to the 6th over 6. Alright, so let's jot that down. 3 to the 6th over 6. Like area or A equals
27. That is the
3
sixth
to
of
the
all vowels of the
6th.
world.
over 6. Alright. Good.
The number is really just what you're doing to it. That when you say it, so n is just what you're doing to it,
What do you mean by doing to it?
what the function is.
Right. Okay, try this one. Let's say g of x is, no, stick with f. Let's stick with f. F of x is still x to the fifth,
Yeah, above 27.
and let's do it from, let's say, 0 to
20.
20. Right, why not?
Oh, wait, it's to the 5th. Oh, oh well.
It doesn't, y'all are doing it anyway, so it doesn't
Okay.
matter. Alright, what's your area?
You mean
20
1200?
to the 5th over
You
6.
said 2000.
20 to the 6th over 6.
22 to 6
12
over 20.
It tears your dream apart every time.
Okay, now, the pièce de résistance. F of x is x to the fifth, jot it down.
Thanks, dude.
Michael, your handwriting's so beautiful.
And you're just
Going from 0 to b.
I directly gave you something left-handed. He can literally write better on that board than I can do.
Yeah.
It's
Alright,
hard to write. with
what
these
is your
lines.
area?
B to the
Beat
6th.
said this.
Wait, you know what, let's make it even better. X, 0 to x.
They
Zero
have to
to
get
X.
this. They have to.
Just say 0 to x, okay? Now, what is your area?
X to the 6 over 6.
Write it down.
This is atrocious. I'm gonna cry.
What is that?
I'm it's X to the 6. It's
6. I don't know what you mean by that. What is that? It's that.
What is it in relation to F?
You took off the
It's-
glasses, man. Why? It got
Power
so-
higher than. It's an antiderivative.
Yeah!
It's an antiderivative. Yes! Yes!
It is the antiderivative. That's all you have to do is take an antiderivative.
I'm literally. It's a 6. Yeah.
You're sad.
I did it.
You're a man sad of hope.
Woo! Holy crap!
I'm sorry.
I'm not saying holy crap in a bad way.
That's a
The area
It's
is
the
simply
the antiderivative.
the antiderivative.
And this is why
Did
everything
we
in
go through
second.
all
And
of
this is
just
why.
to find that? I think we
And this
got
is why
that
in second
one close.
semester I hear so much about the antiderivative.
Yeah, we did all of that like in
It's
a
because
day, and
of
it was
this.
just
I know, we
slash.
blitzed through it. I don't even, I think I just told it to you. I'm like, alright, here's the
I mean, you guys sure.
Well, because you
But
don't
with
have the
that-
time.
the-
Like,
With that last one, I mean, it had to be
Yeah.
staring you in the
Yeah.
face.
I was trying.
It was literally, I'm like 5. You raise the power divided by the power you just.
So now,
And that's
what
why.
happens if I do sine?
Just.
Just take the antiderivative. Let's do it, y'all. Oh, good stuff. Good stuff. Whew.
I did
it. That's nice.
Was the watch on a bed or something? Like you
No,
can't find
he
the
took
actual
it off to
watch.
get serious.
No, because it was
right
there
on
was
the
a
board,
writing on
yeah.
the board. It was like jiggling on it.
To get serious.
Yeah.
Yeah.
You gotta take off jewelry. You gotta make sure you're. It's
What
probably
are you
trying to
gonna do?
Jack.
What are you gonna do
Jack
if
was
you
gonna
see
come
them
off soon.
walking here? You gonna erase it or?
I'm erasing it now.
What they
My
can see on
pretty
camera, Mr. Floyd. They're
Yeah,
gonna
but
see-
they'll see it at the end of class,
Yeah.
not beginning.
He'll know when to pause it. He knows what we're doing.
So when you see them walk up more pods, and make them figure it
Yeah,
out
I'm still
themselves.
doing new stuff. I said everything.
All right.
So what do you think they can
Just-
figure it out?
just slowly
Do what?
moving,
Do you think
slowly
the
moving.
fourth block can figure it out?
I'm just trying
Oh,
to
no.
mess up my old algebra 2 skills.
I don't know, if they
Algebra
didn't
all over
see,
again.
Sloan might be
I
able to
mean-
push him in that direction, but it's a really fine line between giving them hints and then tell them what it is. Cause honestly, once you got to that part, there was nothing else to say other than, nah, there it is, you know, there it
So
is.
you gave us the many hints as possible without giving it to us.
Yes. Now, we discovered it with polynomials,
Yes.
okay? And the connection is that the antiderivative is your area, which means that all the other areas are simply
The antiderivative.
antiderivatives, okay? So let's say f.
I'm guessing this is just proven somehow we don't have to
Yeah,
figure
why
out why
did
it's
we
proven.
ever do that
Correct.
thing?
Okay,
It's
it's Cause like, you normally can't say, this, oh,
There's-
this is the antiderivative, okay,
There's
everything
a
else
beautiful
is-
proof in the back of the book, but it, again, with
Man,
sines
those
and
are some
cosines
long
and stuff like that, they do it
calculations. They
generically
took
with
pages
F,
upon
yeah.
pages, but you don't know anything about notes. You never took any.
Okay, let's do the one that we stumbled on yesterday, so let's actually do it, okay? F of x equals sine x on the interval from 0 to pi. Okay, can y'all picture that?
Mhm.
Alright, 0 to pi would just really be one hump. Okay, and it does continue on that way. So this is the area we're looking for. It does peak out at 1 here, 0 here, pi here.
Oh, Floyd, I got one question.
Yeah.
Do you think they're gonna get all the way to where we are now? I don't know when you started today with.
In fact, this is the only thing we've done today.
Like,
All we did in the beginning was like 4 or 5 homework problems, review homework stuff, and then we spent the rest
So
of the
they
time.
can skip through that if they want.
Right, in fact, they can jump right to this if they want. This is the only new thing we've done, is it?
And that was like what? How long?
We spent maybe an hour, but oh yeah, we did
We
talk about, we went over the quests and
But
talked
we
about
didn't
what the
record
right
that.
answers were and so they could see that,
There's probably like less than an hour of footage.
yeah. Yeah, of actual stuff that we've done, new stuff, 10 minutes, maybe 20, 30 minutes of,
If you want them to struggle.
homework, but then we didn't record us sitting here talking about the quest. So we started the problem before.
So if you want less
So
them
they
struggle
should be
for-
able to get through everything completely.
Yeah.
If you want them to struggle for 30 minutes and just not play the thing, make them figure out
Yeah,
how.
figure out what it is. Okay, here we go. point this out. It is the antiderivative from 0 to the ending minus 0 to the beginning. Okay? So just keep that in mind, that it's the ending kind of area minus the beginning kind of area. Oh, they're here. They can join in. All right, so go.
Okay, so this is the antiderivative of sine x.
Correct.
Which is cosine.
Try again.
Negative cosine,
Negative
negative
cosine.
cosine, that's one.
All right, so let's evaluate the ending point. And let's evaluate the beginning point. All right, what is the negative cosine of pi?
0.
Try again. Cosine of pi is negative
Oh,
1,
Which is
multiplied by negative 1, and you get positive 1.
I'm thinking pi half.
What is cosine of 0? Well, cosine of 0 is 1,
Negative.
and then we multiply by negative 1, we get negative 1. So we're going to do the ending minus the beginning. That area is 2.
Makes sense.
It's reasonable.
See it, that's going up 1, that's pi. so-
This is a 1 by pi rectangle, which is a little over 3, and then, you know, shave some of this out, shave some of that, makes sense. Okay.
You'll have fun learning it.
Enjoy.
All right, I think we're done.
Hit the button.
Hit the.
There should be a red button on the back.
Red button on the back?
Yeah, it should, if you feel on the back, it says really long.
I think someone taller than me is gonna have to do that. Well, that's what Graham.
Okay, that's it for today, y'all. We're gonna streamline this and fine tune it.
No, Michael, don't put your face.